Welcome to problem 8.47. This problem comes from section 8.6 in your book about buffers. You may be just having a hard time recognizing or understanding what a buffer is. A buffer is a solution that maintains the pH by neutralizing an acid or a base. So it buffers that change in pH that you would expect if you add an acid or a base to it. And the best buffers that are going to work the best are going to be buffers that are a weak acid or a weak base and the salt of that weak acid or that weak base. So it's a lot of times we just say it's a weak acid and it's salt. So remember, a salt is an ionic compound. It's a metal and a non-metal. So it needs to look very similar to the weak acid, but it's going to be the salt of it. So if you need to, and you'll be given this on your exam as well, you're going to be given a list of strong acids and strong bases. So if you look in your book, or you can use your book or whatever's been uploaded on Blackboard, you can see what's a strong acid, what's a strong base, and that will help you. So for bases though, actually, your metal hydroxides are going to be strong bases. So if we look here at A, we have sodium hydroxide. And we know that this is a strong base. So we're going to label it as a strong base. And this is its salt. So it looks very similar to NaOH, and it's just replaced the hydroxide with the chlorine. But it's a strong base. So it cannot be a buffer because buffers are weak. Acids are bases, and they're salts. We look at B, and you look at your table that's in the book, we have carbonic acid. And it is a weak acid, so we have a possibility here that this could be a buffer system. And if we look here, all that's been, so our hydrogen has been replaced with a sodium metal atom. And a salt is a metal, or a cation, an anion, however you want to think. So this is a salt, and it looks very similar to our carbonic acid. We've just replaced these hydrogens with the metal to give us a salt. And so this would be a good buffer system. HF, hydrofluoric acid, this is a weak acid, and this is its salt. So the hydrogen, once again, has been replaced with the potassium metal, and which makes the potassium fluoride salt. So this would also be a buffer. In D, KCl, we have two ionic compounds here, so these are both salts. But the definition of a buffer is that it has to be a weak acid or a weak base and its salt. So if we're given two salts, this cannot be a buffer system. So the first thing you want to look at is whether or not you have a weak acid or a weak base. If they're strong or you don't have an acid or a base present at all, like in D, then it's not a buffer. If you do have a weak acid or a weak base, then you look at the salt, and you should just see that here in this example, the hydrogen replaced with a metal. We know a salt is an ionic compound, a metal and a non-metal, and if you have its salt, then that would be a good buffer system. I hope this helps with problem 8.47.